Hello and good afternoon to all of you. I hope all of you are doing well. So in today's class, we are going to learn about object-oriented analysis and design using UML. Now, object-oriented analysis and design is a software engineering approach that tries to model a system as a collection of interacting objects. Objects are basically representation of real-world entities of the system that is being modeled, and it's characterized by class, uh, the state variables, or the member variables and its behavior. Right now, as of now, it may be difficult for you to understand what an object is, but an object is nothing but the realization of an entity. So, for an example, if I say a teacher teaches a student, so teacher is also an entity, student is also an entity. So here, in case of object oriented analysis and design, what we do is we model the entities into objects, right, which has its own class, its own set of variables or data member. It has member functions of its own using which it exhibits behavior. Now there can be different types of models that may be created that represents the system, right? Again, the models can be static in nature. The models can be dynamic in nature, or model may represent runtime deployment. So various models can be created that shows the structural aspect, the behavioral aspect, and the runtime deployment aspect. Now, in this chapter, what we will be learning about is we will be learning about ways for creating different types of models using a representation platform that is called as Unified Modeling Language. So as of now, what we've learned is we've learned that in case of object-oriented analysis and design, system is perceived as a collection of interacting objects, where objects are representation of real-world entities, which are characterized by its class, attributes, and behaviors. Okay, there are different models that can be created. These are structural model, dynamic model, and runtime deployment model. So we'll be using UML as the basis for expressing these models. Now, the important aspect that you need to understand is the difference between object-oriented analysis and object-oriented design. Now, object-oriented analysis tries to perceive the system as a collection of interacting objects and a relationship between them. And it tries to create a conceptual model that highlights the functionalities that are performed by the objects. Okay, so object-oriented analysis design applies object-oriented modeling techniques to analyze the functional requirement of the system. So first what we do, we identify the objects, we identify the relationships, and the way how the functionalities are being performed by the objects. Now in case of object-oriented design, the conceptual model that is created in case of object-oriented analysis is transformed into implementational specifications, take into consideration the architecture specific constraints and any functional and non-functional constraints. So object-oriented analysis focuses on what the system does, and object-oriented design focuses on how the system does it. Now let us move on to object-oriented analysis in this detail. So object-oriented analysis looks at the problem domain with the aim of producing conceptual models. So what does this conceptual model has in it? It has in it the set of objects, the relationship, and the behavior that is to be executed in terms of functionality, right? So object-oriented analysis looks into the problem domain with the aim of producing conceptual model of the system that exists in the area to be analyzed. So analysis model does not take into consideration any of the implementational constraints. Okay, so this is very much important for you to understand. So whenever you analyze, what we do not do is we do not take into consideration any of the implementational constraints. Now, source of analysis can be any specification document or vision document or interview that we have held with the stakeholders. So the result of the object-oriented analysis is a description of what this system is functionally supposed to do in terms of conceptual model. So here what we have learned, in case of object-oriented analysis, what we tend to do is we tend to identify the objects and the relationship between them and create a conceptual model out of it. But analysis model does not take into account any of the deployment constraints or any of the implementational constraints. The source of analysis may be a requirement document, or it may be interview, or it may be any of the focus group session that you have held with the stakeholder. And the result of object-oriented analysis is conceptual model that tries to represent all the functionalities that are to be attained. Now, in case of object-oriented design, the object-oriented design, what does it do? It basically transforms the outcome of the object-oriented analysis phase. That is, it takes in the conceptual model and creates an implementation specification out of it. The way how it has to be implemented, the way how the classes and interfaces are to be implemented, by taking into consideration some of the design constraints as well as non-functional as well as technological constraints such as throughput, response time, runtime platform, deployment environment, and programming language. So in case of object-oriented design, what you tend to do is you tend to take into consideration the conceptual model and transform it into implementation model in terms of realizable classes and interfaces, take into consideration the various constraints that are associated with the architecture and the technology. Now let us try to discuss some of the concepts that are associated with the object-oriented analysis. Right? Okay. So we have the first concept that is called as object. Now an object is a thing that performs a set of activities. So, for an example, a teacher teaches a student. So a teacher is an object that performs a set of activity. So anything that performs a set of activity is called as an object. Now object is characterized by attributes, methods, and identity, right? So attributes are the state variables that stores the state information about the objects. So these are variables of type object that stores the state information of the object. Methods, these are behaviors that are exhibited by the object. Okay, methods are the behaviors that are exhibited by the objects by using the values of the attributes. Okay, so these are the functions that works on the values of the attributes. So whenever an external object requests for an operation to be performed to an object, the object performs the behavior that's called as methods. Now identity is used in order to distinguish or create a distinction between different objects. So every object has to have an identity. So Mohan Pradhan in Sikkim University has an identity. So he's with him there is a specific employee code associated. So it distinguishes Mohan Pradhan from any other object in this particular university, right? Okay. Now the next important concept that we have is called as class. So a class is a structure of the object. So as we have already learned in C++ programming, this is a class is a definition of the object, or a class defines an object. So what class has in it? Class has in it the set of attributes and set of methods. Okay, so a class is a structure of an object. Meaning of all the items that are present in that are supposed to be defining an object is placed in the class. So a class is defined by methods, attributes, and methods. So attributes, these are the data that refers to the object state, and methods, these are the functions that are exhibited by the objects. Now, next important aspect is called as abstraction. Now, abstraction is the process of limiting the information flow. So, it is the result of generalization that tries to reduce the information content regarding the aspect of interest. So, abstraction is basically used in order to for exhibiting information hiding or reducing the information flow between the different aspect of interest. So abstraction is the process or result of generalization for reducing the information content, right? So now encapsulation is a way of packaging the data and the functions of a particular object into a single unit, so that access from the external objects can be limited, and the integrity of data and the functions can be preserved. So encapsulation is a mechanism for packaging the data and functions into a single unit that is not accessible to the external objects, right? So in a way, encapsulation enables us to preserve the integrity of the data as well as the member functions. So whenever objects interact, they simply interact by passing messages. So since invocation is not allowed, so what we are doing is we're preserving the integrity of the data as well as the function. So by preventing the user from directly modifying the attributes and forcing the user to use user-defined functions in order to modify them, data integrity is thus ensured. Okay, right? So this is a very important statement. So with the help of encapsulation, what we can do is we can preserve the integrity of the data. So there are different types of access specifiers or different labels of access defined associated with encapsulation. So we have public, private, and protected, as you already know. Public basically means members are accessible to uh, to members are accessible outside the class. Okay, so what you can do is you can access the members outside the class. So if a member has a public access specifier associated with it, so it can be accessed outside the class. Protected, a member can be accessed from within the class as well as from the derived classes. And private basically means it can be accessed only by the members of that particular class. So public, functions of all classes may access the data or the methods of the class. Protected, data access restricted to functions of the class and the inherited classes. And the private, data access restricted to the methods of the particular class only, right? Now let us talk about inheritance. So inheritance is a mechanism of deriving a new class from an existing class or existing set of classes. Inheritance allows for you to derive behaviors from a class or a set of classes into a new class, right? The main advantage of inheritance is is that what you can do is you can define a new class from the existing class and incorporate new attributes and methods into it as well. So, or inheritance also facilitates reusability, because since you are deriving attributes and behaviors from the base class, you need not redefine it or you need not build it from scratch. So one of the important provisions of inheritance is that it facilitates reusability. So there are different types of inheritance you have. You have simple inheritance, you have multi-layer inheritance, you have multiple inheritance, you have hybrid inheritance, you have hierarchical inheritance. So based on your requirement, what you can have is you can have different forms of inheritance implemented in your design. Now, polymorphism. Polymorphism is basically is a mechanism for having multiple instances of same aspect of interest. So, for example, if you want to have multiple functions by the same name that is capable of performing different operations, so what you can do is you can use polymorphism to exhibit that, right? So, polymorphism can be of different types. You have runtime polymorphism, you have compile time polymorphism, where in compile time polymorphism you have function overloading and operator overloading, and in case of runtime polymorphism you have function overriding. Okay, so polymorphism is a Greek term that used to refer to existence of multiple forms of same aspect of interest, right? So you must have been through polymorphism in case of your C++ programming classes. So we'll discuss about it and we not worry about it, right? So methods. So methods are a very important aspect of object-oriented systems. So methods are behaviors that are exhibited by the object. So whenever a message is communicated to an object, the message has information about the code that is to be exhibited. So if I write a dot add 1 comma 2, it means that I'm requesting the object a to perform its behavior of adding two numbers, that is 1 and 2. So every message has a information about the method that is to be performed whenever the object receives that particular message. So in other words, the message determines an object behavior and the code determines how the object carries out the message. The code that is associated with each message is called as a method. So when an object receives a message, it determines what method is to be performed, and passes the control to that particular method. An object has many methods that may enable it to perform different operations or different actions. So methods are nothing but behaviors that are exhibited by the objects that the object uses in order to perform a specific activity. Now, the next important aspect is called as message. So, as I've already said, message is a medium of interaction between different objects, because in case of object-oriented paradigm, invocational relationship does not exist. So here, objects interact with each other by passing messages. So where with each message, what you have is you have information about the code that is to be executed and data using which the code is to be executed. Now, message passing is the method of communicating messages between various objects of interest. Now, let us go through some of the notable advantages of OOD. Some of the notable advantages of OOD include simplicity, modularity, modifiability, extensibility, okay, reusability, and maintainability, right? So, simplicity. So here, in case of object-oriented approach, what we tend to do is we tend to create a resemblance between the real world entities and the logical entities in the system. So the interpretation is very simple, and you may be capable of creating a very clean, concise, and a correct representation of the system. Modularity, so each object forms a separate entity whose internal working are decoupled from other parts of the system, right? Modifiability, so since the data as well as the data is decentralized and modules are capable of exhibiting their own behavior, so bringing about a modification to the behavior of the object is very easy, right? Extensibility, what we can do is we can use inheritance in order to derive new classes from the existing classes, where the new classes extends the behavior of the existing classes. So that is one of the important features of object-oriented paradigm, right? Maintainability, so objects can be maintained separately, making location and fixing problems is very easy. And reusability, so objects can be reused in different programs, right? So in today's class, what we learned about is we have learned about what is object-oriented approach. We have learned about how object-oriented perceives the system as, right? We have learned about what is object-oriented design. We have learned about object-oriented analysis. We have learned about distinction between object-oriented analysis and object-oriented design, and the very purpose of object-oriented analysis and object-oriented design. Then we have learned about various concepts of object-oriented paradigm. We have learned about objects, we have learned about classes, we have learned about abstraction, we have learned about encapsulation, we have learned about inheritance, we have learned about polymorphism, we have learned about methods, message passing, and messages, okay, and we have learned about some of the notable advantages of object-oriented approach of software development. So in the next class, we'll be learning about the object-oriented concepts in a greater detail.